Hello, today I'm going to explain how the valence electron models and how they work with one another. So with the first example, we got lithium oxide. In lithium oxide there are two lithium ions, or lithium atoms, and one oxygen atom. Lithium has 3 electrons while oxygen has 8. In the outer shell, lithium has 1 valence electron, while in the outer shell of oxygen has 6 valence electrons. Because lithium has 1 valence electron on the outer shell, they want to try and lose the valence electrons in order to get to a noble gas configuration. So when both of the lithium atoms give away their valence electron and give it to oxygen, oxygen gets 8 valence electrons on the outer shell, while lithium loses its outer shell altogether. With the full outer shell of lithium with 2 atoms on its shell, or 2 electrons on its shell, and oxygen with 8, they both are in noble gas configuration, with lithium acting as helium and oxygen acting as neon. Now, for the second example, we got magnesium sulfide. With magnesium sulfide, there is 1 of each atom, 1 magnesium atom and 1 sulfur atom. Magnesium has 2 atoms, or 2 electrons in its outer shell, while sulfide has 6 on its outer shell. In order for both to obtain the noble gas electron configuration, magnesium will give up its 2 outer electrons, or valence electrons, to sulfide, or sulfur. So sulfur will have 8 valence electrons, or electrons on the outer shell, and magnesium will lose that shell altogether. Magnesium will have the same electron configuration as neon, and sulfur will have the same electron configuration as argon. For example 3, we got beryllium fluoride with 1 beryllium atom and 2 fluorine atoms. Beryllium has 2 electrons on its outer shell, and fluorine has 7 on its outer shell. Beryllium will want to transfer its 2 electrons, 1 to each fluorine atom, so that fluorine has 8 on its outer shell for each of them, and beryllium loses the shell altogether. Beryllium will then have the same electron configuration as helium, and fluorine will have the same electron configuration as neon. Neon and helium are both in the noble gas configuration because they're both noble gases. To determine how many electrons go on each shell, we use the equation 2n squared equals the number of electrons in that orbital. So if n was 1, that would be orbital 1. You square 1, you get 1, and multiply by 2, and you get 2 electrons on that shell. If you went to orbital number 2, you would do 2 squared times 2, which is 8, and there would be 8 on that next shell. On the third shell, it would be 3 squared 9 times 2 is 18, and there would be 18 on the next shell. None of these examples have over 3 shells, so that's all I was going to go for. Thank you. Goodbye.